We have 3i Atlas updates, and maybe even our finest chance yet to plainly view the third interstellar entity ever found passing through our solar system. ESA recently discovered something near 3i Atlas that cannot occur based on our present knowledge of comets. Imagery taken by ExoMars' Trace Gas Orbiter demonstrates a diffuse, glowing blob acting unlike any comet we've ever recorded. Its sized negative polarization came in at 2.77%, a figure so extreme that researchers are rushing to revise their models. Its dropping mass, evidenced by a gas cloud that surrounds it, formed as it warms up while approaching the sun. This traveler between stars exceeds 33 billion tons, about 1,000 times the typical mass of a comet. Yet, it exhibits almost no wobble in the gravitational field, even while actively venting gas. The timing looks perfect, maybe too perfect, as its path sat within only 5 of Earth's orbital plane, and it arrived precisely when Mars, Venus, and Jupiter were ideally arranged for observation. The European Space Agency released these pictures on October 7, 2025, just days after 3i Atlas came nearest to Mars at 18.6 million miles. In the image, the halo around 3i Atlas covers roughly to elements of the resolution, to pixels with widths roughly half as large. If space mysteries hook you, hit subscribe to keep up with this unfolding story. Particularly remarkable is that ESA captured them with gear never designed for this goal. The CaSSIS camera on the ExoMars Trace Gas Orbiter was designed to image Mars's surface from just a few hundred miles up. Nick Thomas, principal investigator of the camera, acknowledged that the observation was incredibly challenging. The comet was 10,000 to 100,000 times less bright than their usual targets. Even so, they pulled in data that's reshaping our understanding of interstellar objects. The frames show 3i Atlas as a bright, fuzzy nucleus wrapped in what scientists refer to as a coma. But this halo isn't right for a run-of-the-mill comet. The visible haze stretches roughly 680 miles from the nucleus, large, yes, until you recall that Hubble saw it reach 4,000 miles when the body was much more distant. That apparent shrinkage doesn't mean the comet is diminishing. It's simply that the CaSSIS camera sees only the brightest, densest portion of the gas cloud. Harvard's Professor Avi Loeb has been poring over these images intensively. His group found the object's brightness profile fails to resemble any known comet. Ordinarily, sunlight scattering from cometary dust yields predictable polarization patterns, basically how the light waves align after reflection. But 3i Atlas breaks these expectations. Its strongly negative polarization implies dust particles fundamentally different from anything in our solar system. They may be rougher, more irregular, or made of materials we have never seen before. Where it gets truly bizarre is in the mass estimates. Using information from 227 observatories worldwide, researchers followed tiny path deviations from outgassing ice turning to vapor and providing small thrusts. Those deviations were astonishingly small, under 50 feet of acceleration per day. For something venting gas visibly from thousands of miles that weak push points to one conclusion, the target is extraordinarily massive. For perspective, the famous interstellar visit around Oumuamua was pegged at about football field size, with a mass near 100,000 tons. 3i Atlas, at 33 billion tons, is literally 330,000 times heavier, akin to a truck compared to an aircraft carrier. The nucleus by itself is estimated at 3 to 5 miles across, excluding the surrounding gas cloud. That enormous mass poses a challenge to established theories. Given estimates for rocky material density in interstellar space, we shouldn't expect objects this large. The odds of one passing through our solar system are microscopic. Yet, here it is, arriving at just the right time to be seen. Chemistry provides an additional layer of mystery. The Spheric Space Observatory saw carbon dioxide reaching at least 216,000 miles from the nucleus, close to the distance between Earth and the Moon. But here's the odd part. Though CO is prevalent in comets, its distribution in 3I Atlas defies conventional patterns. The gas seems to erupt in discrete jets rather than uniformly, hinting at an irregular surface or even artificial venting sites. Trajectory analysis may reveal the most intriguing anomaly. The object's path is lined up with our solar system's ecliptic, the flat plane of the planet's orbits, to within 4.89. Statistically, such alignment has under a 1% chance of happening by accident. More curious still, its arrival direction sits within 9 of the origin point of the famed WOW. Signal of 1977, the enigmatic radio burst some once suspected could be extraterrestrial communication. The timing of 3I Atlas's appearance feels almost orchestrated. It cleared Mars when the red planet was ideally placed, will swing by Venus at a great angle, and reaches perihelion just as Jupiter offers a helpful gravitational assist for any follow-up path. Such alignments would impress even a targeted mission. For a random visitor from another galaxy, they reflect an almost incredible amount of luck. ESA's Mars Express tried to capture spectra, the object's chemical fingerprint, but the initial outcomes are baffling. The SPICM and OMEGA spectrometers reported unusual ratios of the elements. Preliminary rumors suggested nickel without iron, an almost impossible natural pairing, but scientists are being cautious pending more data. What we're seeing challenges the fundamentals of how comets form and behave in our solar system. Comets come primarily from two reservoirs: the Kuiper Belt beyond Neptune and the Oort cloud at the far edge of the Sun's reach.